So is everyone able to see that landing gear?
Yep.
So like I said before, there's a couple areas where we have to catch up on a lot of little things, and this is where kind of some of it comes in. So there's a whole bunch of, I would say, more of indicating systems. We classify them as how we indicate different things. And again, they fall in the electrical side. So before we get started, I wanted to remind, so if you have a chance, at break, I've put a handout on D2L for the latching circuit. It's in the under content, under latching circuit, and you'll see there's the lab and then there's a handout. It's only 2 pages. So at the end, I was going to take a few minutes near the end and go through the latching circuit schematic so that you have it. What I'll do is at that point, what I'll do is maybe record the screen, and then I'll upload that to your D2L so you could go back once if you want to print it off. I know it's a little late, but if you wanted to print it off, you could go back through and kind of highlight it yourself if you can't get to it today. So today you may be able to just watch and learn, and then you can go back to the video and highlight your schematic so you understand it. What happened here?
Volkswagen, das Auto.
Just to make sure that the Volkswagen guys are awake today.
How else are you supposed to get us started, Brad?
I like the rubber hammer. That's a good good choice. Good tool.
Hey Brad, is that a homemade video? You used to have one of those.
No, I can't say that one was mine. So a couple of switches, pressure switch, thermal switches, position switches, and that would include micro switches, and then proximity switch, and then limit switches. So we're going to go through those to talk about them, where you have them, why they're there. So again, a pressure switch, or a switch in general, right, is to interrupt the flow of current to a component that it controls. So we're going to use it to control something. So again, you can see here different types of switch. This one would be a pressure switch. These ones would be temperature switches or thermal switches. So let's see. So where would you use a pressure switch? start it off. Look like everyone's about equal. Oh, almost 70% are awake within a minute. It's unusual, first thing in the morning. Oh, two more people just woke up. So, let's look at, does anyone know where would you want an oil pressure switch? So, and again, remembering why would I want a switch to interrupt my current flow? So anyone answer why or where would an oil pressure switch come in? No? So I want to probably know my oil pressure, which is right. I want to know what the oil pressure is. But where would I use an oil pressure switch?
Somewhere in a variable pitch prop.
It's possible. Does anyone know what the switch in the diagram below is? So one of the common uses for oil pressure switches, like this one here, is for your Hobbs meter. Does anyone know what a Hobbs meter is?
It measures your hours, doesn't it?
Yeah, for your engine. So it only makes contact when the engine's running, right? Builds up oil pressure, and then it makes connection so that it keeps track of the engine's hours by when the engine builds up enough pressure. Fuel pressure. So again, a lot of things we want to know to measure it, but would we need a fuel pressure switch? So I'm going to go into your janitrol knowledge. Not there yet. So yeah, the janitrol has a fuel pressure switch, right? So it can cut off the fuel. Tire pressure, that's coming out nowadays, and you want to monitor it, but would you need a switch for tire pressure? Probably not. And again, hydraulic pressure, and yeah, you probably would want to switch to, if the pressure got too high, to stop it from damaging it. So looking at the pressure switch, so again, it could open or close a circuit when I hit a certain pressure. So that could activate a light in the cockpit. It could shut off or turn on an electric pump. And again, one of the easiest ones to remember is the Hobbs meter, right? So the aircraft produces oil pressure, switch closes, and the Hobbs meter counts your hours for your engine. So thermal switch. So again, a temperature sensing switch. We want it to activate or operate a light, possibly open a valve. So I'm going to ask you this: where would you want a thermal switch? I believe almost there. So again, yeah, you probably want to know what your oil temp is, right? And you would, if there's a over temperature, you want to activate the light. Same with hydraulic. Fuel temperature, possibly. No one picked carb temperature or intake temperature. And what, 40% said all of the above. Position switches. So what it's going to do is open a circuit when a component has reached a position. So typically landing gear. So you got the light, the motor, and the horns, all operated by switches. Throttle switches activates the horn if your gears retracted and you move the levers to a low power setting to warn the pilot that the gear's still up. So again, all can be done by switches. So if we look, here's a few examples of your micro switches. So you can you can see it's a very tiny switch that is activated by the lever. So this one's just basically a curved arm, and the middle one here has a wheel. So that when something contacts this, it will actually activate the switch. So the switch part is only, it's only right here. So again, it's a very tiny micro switch, but using an arm or a lever, we can activate it, which makes it nice that we can mount it, again, close to moving parts so that we can get it to open and close 4 flaps. So fully extended, fully retracted, and it will stop the travel. So looking at this one, basically a simple stall switch. So if you can see, this is basically the leading edge of your wing, and sticking out in the airflow is a metal tab. Airflows like that. Aircraft pitches nose up, and the tab is then put into the airflow, and it pushes upwards, and makes contact with that micro switch. And that micro switch is attached. Again, one is ground and one is your sensor going back to your stall warning. The one at the top looks like it's connected to a control surface. So same thing, as the control surface moves, it's going to move and contact the micro switch. Just to make sure that Lynn's awake. Haven't heard him all day today. So,
No, but I was listening.
oh, he was here. He's there, attentively listening.
I was listening to you and Brett discussing how you're going to inflict pain on us for the rest of the
Oh,
weeks. You didn't know you were on live, Mike.
I realized after, yes.
Yeah,
I didn't say anything.
Yeah,
You're all so quiet.
that's a Dodge Fupai.
So one of the other things we were to talk about is proximity switches. So you can see in this picture, it shows a bunch of proximity switches. Let's see. Oops. That didn't work. There we go. So my friend Pippi has some nice proximity switches for you to see. So again, you have adjustable threading and to the front of the sensor. I just wanted to show you. Oops, if I can. No, maybe not. Just to show you, in these case, they're using that Deutsch system, which is blocks. So all the proximity centers go into those blocks, and then it runs from the blocks back to the units. So you can adjust them, the depth, by adjusting the nuts where they're going to be placed. Oops. So the box, basically your brains, and then a bunch of sensors. So why would we want to use proximity switches? Well, they do have no moving parts, so we don't have to worry about contacting switches, micro switches. Very reliable. Again, they last a long time, and we don't have them contacting anything. So it doesn't touch the control surfaces. Where would you see them? So again, doors, cargo doors, thrust reversers, so that we know if the thrust reverser is open or closed. Landing gear, flaps, slats, air and ground sensing. So again, they can be used all over the place to sense if something is close So the two main types are inductive and capacitive. So again, they can be rectangular or square, and the round ones, the ones that I showed you. Some of the things or common terms is called the target. So it's looking for the target. The nominal range that it has between the target and the sensor. And then what it has is called proximity cards. And then it has what they call a proximity switch electronics unit, or PSEU. So each sensor feeds back into that electronics unit so that it knows if the sensor is close to the target. So again, inductive.
Brad, what are the prox cards? What's the purpose of those?
So each one, if you go back, so each sensor would have a proximity card in the box. So then the box can tell which each sensor is doing, and then deal with the sensors that way.
Okay,
So there technically would be cards inside the boxes for each of the sensors.
Okay. So it's electronic circuit for that switch then.
It kind of cut out, but I think you said it's electronic circuit.
For that switch, is that correct?
Yeah. So each one has kind of like your computer card. It slides in for each sensor.
Okay, very good. Thanks, Brad.
Okay. So the inductive ones use magnetism. If you go way back to your 605 training, right? So if you use an inductive coil, what it's going to do is when a target, which is going to be metal, becomes close to the proximity switch, it senses the metal and changes its properties. And the proximity sensor can send that information to the box, and then the box knows that the gears come up, whatever it is. And again, used typically in areas that are dirty. So again, landing gear is one of them because it's dirty, fluids all over, and it doesn't bother the sensor, right? Because it's using the magnetism. It just looks for metal object coming close to the sensor. The other one is capacitive. So again, using an electronic field to detect the target, it uses capacitance. Now, in this case, the targets don't have to be metal, and that means I can get higher resolution out of it. The only problem with the capacitive one is they don't work in the environments that are dirty. So oil, hydraulic fuel, all those things on it, it's not going to work. It's going to change its capacitance. So capacitive ones have to be a nice, clean environment. Limit switches. So what we want to do is limit the movement of a mechanism. One of the things would be flaps, right? Stop at their top position, stop at the down limit. And I know certain people may have experienced this already. What happens when the down limit switch or up limit switch is missing? Well, that motor keeps moving, right? And it doesn't stop until something else gives. So you want to make sure that if you're messing with a limit switch, that you know that how to adjust it properly and set it up. So looking at the 415 for the switches, So if you can see on this one, you have a lever. As it comes up, it makes contact with the micro switch and pushes on the micro switch to indicate that the wheels are up. So looking at the landing gear, we have, in this case, the left hand wow switch, weight on wheels. So this one has a wheel because it's moving, right? It has contact with the scissor. So you can see it there. So as the weight on wheels, it's going to indicate again inside the cockpit. So as it contacts that area, it would give a indication into the cockpit. So again, looking from the cockpit view of the 415, you can see in the square, that is your gear, right? The gear lever, so that they can tell if the gear's up. And again, I picked the water bomber because, right, they have to know when the gear's down, when the gear's up. Again, if they're doing a water pickup. So that's the area there where they're looking for the gear indication. So the next little one was flight controls. So again, airframe textbook has some, which is chapter 10. So looking at some of the flight controls, one of them is flaps. I'm pretty sure you've gone through flaps before, I hope. So let's see how much you remember. What do your flaps provide? Oh, I think I caught two people sleeping already. Oh, 3, 4. So if you remember, flaps do provide lift, but they also provide drag as well. So that was the answer. So again, they increase lift, but they also increase drag. Couple of types of flaps, the plain flap, the slotted flap, split flap, and then the Fowler flap. So if we take a quick look at simple, right, the plain flap, Again, section of your trailing edge, inboard of your ailerons, and usually typically gives you 10, 25 to 40 degrees of flap. So again, very simple and easy. So I don't know if Lynn knows this, but I have the answers.
And the hits just keep on coming.
Yeah, I just got to make sure you're awake.
Oh, I'm fully awake.
So one of the things that we want to know is where the flaps are, right? What angle they're at. So that comes into why we want to indicate. So again, looking at some of the angle of the flaps, this one has a separate one left and right. And this one's electronic, giving you a bar graph, and it gives you some warnings for speed where you want to put flaps. So it gives you their degrees. This one gives you a indication down flaps. Split flaps.
Brad, your mic's cut out.
There isn't. But you still don't have a mic.
Should we go on break while we wait for you?
I like that idea.
Put thumbs up in front of Pepe Le Pew there if you agree, Brad. Sounds good.
Test 1, 2, 3.
Yep, we can hear you.
Hear you.
Oh, there it goes. Maybe it was just the connection on my thing. You still hear me?
Yep.
Okay. So we'll come back around. About 9:20.
Sounds good.
Okay.